Your first Newton question, they say that a learner sits on a stool, and according to Newton's third law, they want to know what's the reaction pair or the reaction forces of that, according to the learner's weight. Okay, so you need to know that weight has to do with the force of the earth. All right, so if you go and you explain or put the words of the force of the earth on or into a sentence for weight for this learner, it will be the force of the earth on the learner. Okay, and remember, it's a force, it has a vector, or it is a vector, so it needs direction and it's downwards. So if you want to have the Newton 3 reaction pair, it will just have those two words, the earth and the learner, to switch around. So it will be exactly the same. It will be the force now on the force of the learner on the earth. And again, because it's a Newton reaction pair, it means that the direction switch. So it's now just upward. So that's your original weight, the sentence of weight, and this is the reaction pair. So then your correct option will be D, because you need to read that it's the learner's weight. Okay, if it was the chair, we would have had different words in there. All right. Question 8, we have what we did study a few times now here, in the case of this year, where we have a graph and I want to ask you something about the gradient. So we have a graph of f on the y-axis and a on the x-axis, and we are comparing a and b. And I want to know which one of the four options is now correct. So this is not a difficult one, so you don't need to think about a difficult formula. So we're just using Newton's second law, F net equals ma. All right? So this formula is already rearranged correctly because it fits our straight line formula, which is y equals mx plus c. So what is our y-axis? Our y-axis is given as f. Your x-axis, you can read off from the graph, should be a. And what is left, because we know that is 0 because we have an origin over here, so what is left is m. So you'll see that the gradient of this graph is m. So here we can see that the mass of A should be bigger of the mass to the mass of B, okay, because of the different slopes that we get here. And then the correct option that you can see that will fit that statement will be option C, that says exactly that. Cool. Number 18, it's again to test your knowledge on Newton 3 or Newton's reaction pairs. They say that a man is in a lift and it's moving upwards at a constant speed, and it's in capital letters. They want to trick you here, but then you need to read further, and they say that the man's weight is W. And according to Newton's third law, what is the reaction pair of the man's weight? Okay, so again, I'm just going to do it here on the whiteboard. So you should know that the man that's in the lift and it's moving upwards at a constant speed, it's not accelerating or anything, but that's not the question. The question is what's the weight of the man's reaction pair? So the first thing you need to go and check is what is the sentence for the weight of the man, and that will be, is the force of the earth on the man, and in what direction? It will always go down. Okay, so the force of the man on the earth down. So what's the reaction pair? The Newton 3 reaction pair will be exactly the same sentence with the two subjects changing. So it will be the force of the man on the earth, and the direction changes. Okay, we just swapped those and the direction swapped, so our correct option will be option D. 26, they say a satellite orbits the earth at a height where the gravitational force is a quarter of the Earth's. And in case, well, if the Earth's radius is r, what is the height that the satellite is above the Earth? Okay, but not the Earth's surface. So that's the important thing. Okay, so again, a lot of writing. So here we have the Earth, and then they say that the satellite is orbiting the Earth, and they give it the force or the weight already. Okay, so this is now a reverse question to what we are normally used to. And you should know that from our Newton's universal gravitational law, that the force is inversely proportional to d squared. Okay, so they already gave us that the weight is a quarter of the weight. Okay, a quarter W or a quarter F, doesn't matter. So that means that the force decreased by 4, okay, because that is what happens. So now because of that inverse proportionality, what will happen to D? D will increase, but by how much? Okay, it will increase by 2, okay, because remember we have a square, okay, so it will increase by 2. But they already gave us that the radius of the Earth is given as r or d, doesn't matter. So they already gave us that, okay? So the person or the satellite, I'm just going to draw a stick figure. The person is orbiting the Earth at a distance r already, okay? So they want to know what is the distance from the surface, so that should be r. Okay, so because we have, remember the gravitational law says it's the distance between the midpoints, the middle points. So here it's actually 2r, but they want to know, we have the middle point to be r already, so what is the distance from the surface? It should be, okay, let's just change that. 2r minus r should give you r, and the correct option that fits that will be option C then. All right.